Guys, welcome back. So these are the two coils from the Newman motor, and I wanted to see how they would work outside of the Newman motor environment in one of my big monster rotors. This is the maglev. It's being supported by that magnet there. And it just so happens that this is just tall enough where the screws still catch. I need to put some spacers underneath here because I have a little bit of a gap, but it doesn't really matter because this is locked down tight. These aren't going anywhere. So yeah, let me get my dual JL94 circuit hooked up to these two beasts and see what happens. Stay tuned. And it works really good. I'm getting solid output. It's flashing on the camera, but yeah, those coils are nice. This is at 12 volts. And it's flying. I know the camera doesn't pick it up. I should probably get out of the fire of the magnets, although I do have an extra ring on there, and that ring is made of copper infused PLA. And I think I have, let me get my, yeah, it's continuing to spin up. I gotta get my, I don't know what I did with my, oh man, come on. Here it is. Trying to do this one-handed is not good. All right, let me see if I can get, hold tight. All right, let me see. Oh, is this not working? I think the battery came loose. Oh well. Oh well. I'll get it. I'll change the battery out and we'll find out. I think it's at its top speed right now. So this is 12 volts. Let's see. We crank it up a little bit. And I'm definitely getting solid output. I hope I don't burn out. Whoa. So the, oh, that's not too hot. 80 degrees. The chips are staying cool. It's just the resistors are getting hot. So that is 16 volts. That thing is going nice. Very nice. All right, I'm going to run it. I'm going to take this apart and run it on one coil and see what kind of output I can get, not using the dual circuit out of one of the coils. I could probably just tap into the back EMF coming off of the circuit itself, and that'll tell me. All right, stay tuned. I found another tach meter. 1400 RPM, and that's a big disc for that type of speed. I think that's the max it'll go. Yeah, so 1,430 RPMs for a disc that size. That's pretty good. I'll check it out with my other tach. But I'm getting a solid output. And I know those are blinking on the camera, but they're not in real life, which means I'm getting a lot of back EMF, which is really heating up. '86, 91 degrees, 98, 95 for the resistors, and all right, the diode's not too bad. The bulbs, but the big chips are, that guy's 80. That guy's 85. That guy's 82. But it's weird because they're not even warm. The resistor's warm. That's warm to the touch. That's actually hot. Yow! Yeah, that's actually hot. Yeah, that's 90, 91 degrees, 92 degrees. Yeah, let me shut this puppy down before I fry that circuit. But yeah, that's a beast. And because of the flywheel effect, that thing will spin for at least 20 minutes. Easy. And it's riding on that magnet. It's floating on that magnet bearing, I call it. Yeah, that's pretty cool. Stay tuned. So I actually have two of these. I've got this big one here, and I've got this guy. This guy's now working, and it seems to match pretty much what this guy does. Yeah, 400. So I can use either one. Gotta let the circuit cool down. I wonder if I can put different resistors on there to beef it up. Because again, these coils are monsters, and they're putting back a lot of current back EMF, not just voltage, because of the thick wire. 20 gauge. All right, stay tuned. So I'm pretty impressed. I took a reading just on one coil. I gotta find my stand so I can show you guys. Hold tight. Sorry about that. Yeah, I took a reading on one of these coils, and it was up to 15 volts output AC when the motor was running. So that's pretty impressive for a coil with such thick wire. Usually you get higher voltage out of thinner wire, but seeing it's such a massive coil, I guess that's to be expected. But yeah, that's pretty cool. Almost, yeah, it's like 14.9 volts at its top speed. All right, stay tuned. All right, let me see. I've got everything hooked up. I'm gonna let it get up to speed. Yeah, there we are, 16. It goes down. It starts out really high, and then it goes back up again. Ooh, 15.4 volts, 16, 17 volts. Man, that's crazy. Then it drops back down again. I don't know why it's doing that. I think it's because of the way I'm holding the... And then it'll even out at about 15. Anyway, my wife just turned on the blower, so I'll have to bring you guys back later. Stay tuned. All right, so a little side note. I've got a neighbor that constantly brings me motors because he knows I love them. So he brought me 3 or 4, but these two are kind of interesting. I think this one is I think they're both AC motors. I know this is a ceiling fan motor, but this one has 3 wires, a black and a red one, and then a white one, which I believe is ground. So that would lead me to believe that this might be a DC motor, but I don't think so. I think it might be a universal motor. I don't know. I have to crack them open. But anyway, on to the main show. What I wanted to do was I thought maybe I might have had the coils incorrectly in the Newman motor, which is why I didn't get, excuse me, a lot of speed. Got a lot of power, but not a lot of speed. And so, as you saw previously, I put the 2 monster coils in this rig with the big barrel rotor, and got tremendous amount of speed. And so I realized that no, I indeed had the coils set up the way I always do, start, finish in the Newman motor. So I decided to take the Newman motor rotor out and put it in this rig. And I'm starting it off really close where the magnet actually enters into the coil itself, because I want to see how that works. So let me get things set up and I'll bring you back. Stay tuned. All right, so it's going pretty good. About the same I had when I was running it off of the dual JL94 circuit in the Newman motor house, except when I turn up, now it's flying. Thank God I got the tape on that thing. Putting out a lot of power. Let's turn it up even more. Yeah, see, now it's flying. And I don't know if it's because it's the proximity to the coils. "31 volts at 600 milliamps. It's putting out a lot of power. Let me turn it back down. That's 12 volts, which is the area that I like to work, but I know these thicker coils want higher voltage, which is fine because they can handle it. I don't know about the circuit though. Gets kind of hot. The chips don't get hot, the resistors and stuff, but that's no big deal. But yeah, so let me slide the coils back and see how that does. Stay tuned. So the nice thing about this rig is I can loosen these and then slide. These coils fit perfectly in there. So now I have the coils a little bit separated. Let's fire it up. That's actually spinning much faster at 12 volts. Oh yeah. So the coils like to be farther away from these larger coils. Yeah, that's kind of scary. I got the tape on there, but I don't know. I'm getting a solid output. It's blinking on camera, obviously, but let me turn this back down. At 800 milliamps. "20 volts is a happy medium. Thing works really well in this type of setup. All right, shut it. Let me turn it back down again. Yeah, that's a beast. I want to set up, I want to see what kind of output I have coming off of these coils. And again, it's being held up by this magnetic bearing. All right, let me see what else I can do with this. Stay tuned. So I have the coils even farther apart, and it's clearly going much faster at 12 volts. So yeah, I'm gonna spread them out even farther. That's really wild. I don't dare crank this up even any higher. Yeah, that's a little too scary for me. I keep it right around 12 and a half, 12.7 volts. and getting really good output. So yeah, these big coils like to be farther away from the rotor. I love those coils. Thank you, Redesign 3DP, for making your stuff, which allowed me to make these coils, which are the two best coils I ever made, because I put the connectors on the inside, which frees it up to do a lot of different experiments without having to worry about connectors on the outside. Yeah, I'm going to try some different circuits with this and see how it goes. All right, stay tuned. All right, so I've got a Bedini circuit on here. This is just a generic Bedini circuit with the trigger and run set up, and then the primary, and then the charge. I'm getting no output, but of course this is at 12 volts and the coils are really far apart. And I know that for a Bedini circuit, they like to be closer together. So let me shut this down and pull the coils as close as I can and see what we get then. But it's still working well. Love these coils. Stay tuned. All right, I had to switch out to the other Bedini circuit that I got. I bought two of them. This is 12 volts and it's doing well. It's got an output. And yeah, it's working well. Components are staying nice and cool. Obviously the output is this light, so the neon's not going off. But it's doing well. Let's turn it up a little bit. Yeah, so it works well with the Bedini circuit. Love these coils. I don't want to turn it up too much because I think that's what happened to the other circuit. I burnt it out. It still works, but nice. All right, let's see what else we can do. Stay tuned. So this is a very old JL94 circuit, one that I got a long time ago, and it's working great. I've only got it obviously hooked up to one coil, but it's getting tremendous output. I'm getting a solid light, although it's flickering on here. And so much back EMF that it's also activating the neon, which is always not a good sign, but Sky Collection assures me these circuits can take it. And this is only at 12 volts, 100 milliamps. Yeah, I need to hook this other coil up, see what I'm getting out. Stay tuned. Oh, I don't even know if that was recording. So I've got one, whoa, that's a bright light. A lot of power coming out of the back EMF. Off of this coil, I'm getting almost 17 volts. And that's amazing for such a big ass wire coil. But I'm getting a lot of power, a lot of back EMF. You see, things are heating up over there. Oh no, not really. This is a really old circuit. It's working really well. One circuit, one JL94 circuit powering this coil, Bedini style. I'm sorry. Yeah, just powering this coil. This coil by itself is putting out close to 17 volts, 16.9, which is not bad. Not bad at all. I don't know how much of that other recording. I'll have to look at it before I post it and see where it kind of failed. Anyway, let me see what else I can do, or stay tuned, or maybe not. I don't know. We'll see. Stay tuned. All right, I know which one I haven't tried yet. I want to try a Hall sensor on this type of setup and see how that works. When we get it rigged up, I have to be careful with a Hall sensor. All right, stay tuned. So here's the Hall setup. It's pretty tricky with this one because the magnets are so powerful. finding the sweet spot, but it's working. But if you can see, I move it around. There we go. Yeah, when you find the sweet spot on this thing, it flies. But it's funny because finding the sweet spot, having it fly, produces back EMF, but when I go a little bit slower, it produces even more. There we go. There's the happy medium. Yeah, I love Hall circuits, but they're really tricky to. I mean, they're not tricky to get set up, but in this instance, because I'm rushing, and playing with the potentiometer moves the chip. There we go. All right, anyway, I just wanted to see how, let me turn it off so I burn out the circuit. I wanted to see how this monster rotor from the Newman motor would work in this setup with these coils, and it works great. Not that it didn't work great in the Newman setup, don't get me wrong. It worked fantastic. I love that motor, the RD3DP motor. Right now I'm printing out the zero force motor. I can't wait to get that going. I'm going to wind the coils nicely on that, unlike the other redesigned 3DP motor that I haven't gotten going yet. But yeah, the bigger zero force motor, I'm going to hopefully get that going sooner than later. Anyway, thanks for watching, guys. Have a great one. Ciao.